All right. Okay, hello. Hi, everybody. Welcome back to the workshop. So today we'll be talking about programming stuff. And I designed today's presentation as very basic. So I'm going to be talking about some C# programming concepts. So I mentioned before that Unity uses C# for their as their scripting language. So it's going to be very dense and kind of fast, but I'm hoping to cover a lot of basics that if you've never ever programmed before, that you can kind of get started in understanding how to program. Then I'm gonna point out from basically the script that we had last time. I'm gonna point out a bunch of these concepts I'm talking about in that script that we made, and then hopefully we'll get to expanding the prototype, just with some new stuff that we have on our outline that I talked about. So first is a C# programming concept. So I'm going to try to go through this fast. So anything that you see underlined, again, I'm going to share this presentation. Anything you see underlined are all links. And so even though I'm going through this pretty quickly, if you've never programmed before, I'm hopefully providing a lot of resources for you to be able to look into this in your free time. And also, again, you can always message me as well. So I'm going to be talking about storing data in variables, how to check conditions with if-else statements, repeating your code with loops, performing a routine with functions, and also the big thing that we use for Unity is classes. So I'll be going over that. So to start, we have our variables. And essentially, it's kind of like in mathematics where you have a name and a value. For C# specifically, you need to declare a type for your variable. So you have to say what kind of variable, what kind of data it is. And so we have in C#, at the top right, I have and also here, obviously, the full list. We have integers as int. So obviously it's an integer. I have examples up there. A float is a floating point number. Basically, it's a decimal. And kind of under that is we have a double, which is I think it's a double precision float. So it's essentially just a decimal that has a lot more accuracy. And so if you have, for example, that one has a really long, decimal value. So you can use double for that. But most of the time you'll see float. We have bool, which is a boolean. I don't know where that word comes from. It's just, that's what it's called. And it's either true or false. Very simple. We love booleans. Then we also have a string, and I think the word comes from a string of characters. So it could be either characters like ABC, or words or sentences. So up there, for example, I have the string hello world with an exclamation point, and it's closed with the double quotes. And also, that's kind of the basic data types that we have and how to make variables. But I want to point out something specific that is very useful for Unity is this difference between declaration and initialization, which are two big words. But basically, here at the top we have declaration, which is telling the computer, hey, I have some variable that I called some number and has a type of integer. And it's kind of like a promise that tells the computer, I'm going to be using this somewhere in my code. And then initialization is the part where you actually tell it what value it has. And so you can, at the top we have both declaration and initialization in one statement, but you can split it up into two, which is super useful for classes and what we have in our code with you say one thing and then you use it and set it later, right? Any questions on this? Okay. Very quickly, moving to if-else, we have lovely favorite condition checking, and it's kind of self-explanatory. Is you have this if word, which is a keyword, and then in your parentheses you have your condition. And this condition, it has to value to true or false. And so it's a Boolean type, right? And so you can actually pass Boolean variables that you have saved into your conditions, which could be very useful. They can be chained together, like in this example where I have if, else, if, and then else. Your else statement it's kind of like if my condition, then do something. Else, if my condition is false, the else statement is doing something if my condition is false. But you can have the if statement on its own without an else block as well. So obviously, in this example, if 6 is less than 3, print. So this is just saying print out to my user that 6 is less than 3. If it's Otherwise, if that is false, it's going to go to the next block, right, and execute. If 1 is less than 3, then do that. If that one is false, it's going to have the else statement. But in this case, 1 is less than 3, so it's going to print out 1 is less than 3, and then it's not going to execute the other blocks, right? So it kind of stops when it checks that something is true. So we use this a lot in Unity. We used it last time. I'll point it out later. And kind of going off of that, another thing that you can do is loops, which built off of the condition checking that we have, right? So again, these are all links, and these are all the main types of loops that C# provides. The most simplest are while loops. So at the top is while some condition is true, do stuff, right? So at the very, very top there, I have while 1 is less than 3, I'm going to print out hello world. And obviously, 1 is always going to be less than 3, and so that actually is an infinite loop, which is why hello world gets printed so many times, because it's just always running. So obviously you don't really want to have that in your code, but something similar. A for loop is like a while loop, but with some extra steps, right? So you have kind of like, in this example, well, the formatting is there. You have your setup first, which happens the first time you enter your loop. So when the code first sees your loop, it does that once. Then the second part is the actual condition, which is the same as my while loop. And then the last part, it does every time it finishes the block, right? So in this example here, I have my setup expression. I'm saying I'm making a new variable, I is 0. So it's an integer, and I'm setting it to 0. And then the condition is, okay, is I less than 3? Well, 0 at first. 0 is less than 3, that's true. So it's going to print out I is, and then the value of I. So I is 0. Then when that block finishes, which is just one line, it's going to go to that very right-hand side, and it says I++. And the ++ operator means you add 1 to I. So it's an incremental operator. A very useful shorthand. And this actually kind of format you see for int I is something, it's very common. You'll see it's how you repeat something in a certain amount of times, right? And so you see here I goes from 0 to 2, and then the loop exits. And then the one that I think you'll probably use the most with Unity, and that I love, it's very handy, is a for each loop. So this actually also mentions arrays, which is a collection of data types of one type. It's essentially a bunch of variables, but put into a list, right? So here I have a list, right? It's still a variable, so I call it my num list. But the type, you see, it says int with brackets. So the brackets indicate that it's a list. And you can see, obviously, I'm initializing it to a list in curly braces of numbers, integers, 1, 2, 4, and then 8. So kind of, hopefully very simple, but again, that's also a link. You can look into more arrays there. But the for each loop works on arrays, where essentially you can iterate over each of the values in your array and do something with it. So, in kind of like Unity, when you're trying to do something for a bunch of different objects and you have those objects in an array, this type of loop will be very helpful, right? So here I have, you need to declare a variable that's going to be used inside the loop with the same type as your array. So obviously here I have a variable named num, and it has a type of int, because what it's going to do is pull different numbers from my list and set it equal to num. And obviously that says right here, in my num list. So it's fetching that variable, fetching that list, and then num is first, as you can see on the right, num is set to 1, and then 2, and then 4, and then 8, and then it stops. So it's kind of, shorthand, again, very useful. And there are links there for if you want to read more. Moving on, does anybody have any questions on this so far? This is an example, just real quick, to show that a for loop is a fancy while loop. Because right here in our for loop, we have the setup expression int I is 1, whereas in our while loop, it's just a declaration outside of the while loop. The condition is the same. We're checking if I is less than or equal to 5. And then the expression that happens at the bottom of the while loop is what happens in the right-hand side of the for loop. So in this case, at the top I write I++, which is I add 1 to I, but at the bottom I write I plus equal 1, which is another way of saying add 1 to I. And obviously here, if I write 5, it's going to add 5 to I. And then you can see there that the same thing happens, right? So they execute the same way. Very helpful. Quickly moving on to functions, right? So kind of putting pieces together. A lot of those if-else statements or loops are probably going to be housed within these functions. In C#, they are called methods. So if you want to look up, if you want to Google anything, you want to look into methods. And I'll go over why that's the case later. But essentially, it's a block of code that is only run when you call it, or essentially when you use it, right? It can accept like parameters, which is basically I can give it things and then it's going to do something with that and then spit something back out, right? So think of a function how it is in mathematics, right? So if I give sign 1, it's going to spit a number back out to me. So that's kind of how it works in programming as well. And so it's kind of like a recipe. It doesn't actually do anything until you call it, right? So if I tell it, hey, I give you like a parameter carrot, and then it's a recipe that makes cake, so it's going to return carrot cake. If I give it a parameter blueberry, it's going to make blueberry cake, right? So it's kind of like, it's really handy to reuse it with these parameters. So in this case, I have an example. At the top, I have a function that I call myfunc, and then it's a function because it has these parentheses after it. And then inside of this parentheses, I declare a variable, but I don't initialize it to anything, right? So I just say I have a variable called param1, and it's a type integer, right? And then inside of those curly brackets where it says return param1 times 2, that's what it does, right? So it calculates param1 times 2, and then the return is a keyword, that's what it passes back. And at the very beginning, it says int myfunc, which means that my function returns an integer type. So obviously you know that param1 times 2 is itself an integer, which makes sense because param1 is an integer and 2 is an integer. And then I have it running where it says static void main. That's just kind of the online editor that I was using, but that's just running, and it's saying, it's calling my function with, on the right hand side there, and you know that it's a function call because it has parentheses to the right of the name. A variable won't have parentheses like that. And so you can actually have also functions that don't have parameters, which will just have empty parentheses, which you will see a lot in Unity. In this case, we need a parameter of an integer type, so I pass it 2, and then my function returns something, and I want to save that return value into a variable, so I create a new variable called return val, which has a type integer, which makes sense because my function returns a type integer, and so I need to save it into a variable of a type integer, right? And then essentially, I write to the user the return value. So in this case, that's going to be 4, right? Is there any questions on this? Quickly talking about scope. Since we talked about functions and we talked about variables, we want to talk about scope because this is pretty useful for Unity and also object-oriented programming in general. So on the left is kind of the rules there. Essentially, if you have a variable inside of a function, you can't see it outside of the function. But if you have a variable that's outside of the function, you can see it. And you can use it and do something with it inside the function. So it's kind of like nesting dolls in a way. So I have kind of like an annotated diagram here where my global num variable defined in that box with the blue line, the blue square, you can use that number for whatever you want, both inside of the function printNum and multiply by. But my parameter called num inside of my printNum function, it only exists inside of my printNum function, right? So it doesn't exist in the same spot where global num exists, right? And same thing for multiply by. So multiply by has a parameter named num as well, but even though they're named the same thing, they are not the same value, and so they don't interfere with each other at all, right? And same thing with factor. I have a variable called factor in multiply by, and that factor is not available inside of printNum or inside of that global space either, right? And just to point out real quick, print num, you can see in front of it, it has the word void, and void means that this function does not return anything. You'll see that a lot in Unity. A lot of times with game programming, you want to just do something, and most of the time it won't return anything. It just does something. So void is that's the return type of, it doesn't return anything. Any questions on this? Building on top of all of that, specifically with our variables and our functions and our scope, is objects, right? So we're coming down to what is C#, and C# is an object-oriented programming language. And that's also why we use it for Unity, because Unity, from last time, we have game objects, and those game objects have scripts attached to them that we're writing. And so C#, since it's object-oriented, we have a different object in our game, and so that's why C# is very handy. These objects come from classes, which on this next slide I'll go into what that means. But essentially a class is like a guideline or a blueprint, and you can tell the program, hey, make me a new object of that type, of that guideline, right? Following those guidelines. So, for example, we have a class that I created somewhere else called fruit with a capital F, because classes should start with a capital letter. And then we have different objects. We have apple, banana, and orange, which are objects of that class. So you see here on the right is just very simple with a typo code. You can see the syntax here where fruit is capitalized, and you have these parentheses as if it's a function call, but in front of it you have the word new. And so the word new gives you, it tells you that this is a class, and it's creating a new object, and it's giving it to you, right? So it creates this object, it gives it to you, it returns it to you, and you need to save it into a variable. So I name a variable called apple, but then variables need to have types in C#. So the type of the variable is the name of the class. So the type of it is the class, right? And so these are all separate, by the way. So they all have the same properties because they're all the same class, but they are all individual. So if something changes within one of my objects, that doesn't affect the other objects, right? To go off of that, I want to go to specifically what classes mean in C#. And again, as I mentioned, they're kind of guidelines or blueprints, but they have this main structure of fields, methods, and then properties. In properties, I'll go over what properties are, but personally I don't use them too often for my programming because properties are mostly used to communicate between different classes. And so they might show up when you have some really complex programming in your game. But essentially fields are those variables that we talked about, right? So those are going to be in global space, that they exist inside of your entire class, and they're going to be at the very top of your script. So in this, I have an example right there. I have a class called my class, it's capitalized, and then at the very top I have a field called my num. I'm declaring it to be an integer, and I'm also initializing it with a default value of 5. Then we have methods, which are functions, but methods are functions, but they're called methods because they're tied to a specific class. So if you look into other programming languages, that's why sometimes they're called methods and sometimes they're called functions, but they're the same thing. I'll go over an example of this, but to be able to access methods of a specific class or a specific object, you use the dot operator, which you see a lot in Unity, and I'll go over an example on the next slide. And then lastly, we have properties, which I won't go into too much, but essentially it's a way for other classes to access fields within your class without directly modifying it. So properties allow you to indirectly modify it. And that has to do with object-oriented programming, kind of like guidelines or standards, right? Like you don't, for example, I have a field, my num, which is just inside of this class. I don't want other classes to be able to modify this number, right? That's kind of just practice in object-oriented programming is that this is mine and nobody else touches it. You don't need to know about it. And so properties allow for other people to read the number of that field or to set it if you allow them to set it. And again, I have here a link for access modifiers, which you can kind of see here. There's a modifier called public. So I just said anything in a class exists only in that class. By default, my num at the top is, I believe, private. You can write private if you'd like, which means it's only in this class. By saying public, I'm like, okay, other people outside of this class can actually access this method, right? So there's a link on access modifiers there. The most common ones you'll see are public and private. When we see that in Unity, most of the time it's private. If we do see public, obviously I'll point out why it's public. And then there's the example of this class running. So I have a field, my num, default value is 5. I have a property which looks like a function because I'm saying it's a public method. It returns a type integer because my num is an integer. And I name it out of good programming practice the same as my field, but with an uppercase because it's a method, and methods should be uppercase letters, and fields are lowercase, start with lowercase letters. So it's the same thing with an uppercase letter. And then you see this fancy notation that says get with curly braces and then set with curly braces. And it's like basically a whole thing where I have an example, I'll talk about it real quick, but if somebody outside of my class tries to say my num as if like a method, and like they're only reading it, like they just want to get what it's set to, then that's what the get is called. So it says return my num. Makes sense. But if they're saying like object dot my num is equal to something, then it's going to automatically call the set method. And it kind of like C# kind of does this for you, so you don't have to actually call get or set on your own. And the word value, as you see, it's not like a variable. Value is just, it's like implicitly defined by C#. So C# kind of does a lot of cool things for you. And again, that's used for stuff outside of my class, accessing the fields inside of my class. And at the bottom, we have our methods, which are the functions that we talked about. So in this case, we have add5, which is public, which means somebody outside my class can see that this is a method that I have. It's going to return nothing, which is why it's void is there. And all it does is it adds 5 to my num. And as you can see here, I could just say my num without declaring it because it's declared all the way at the top, right? So as we talked about with scope before, my num exists inside my entire class. And then we have another method, print num, which is another public one, and it also returns nothing. And all it does is it shows to the user the value of my num. And so on the right here, I have an example of it running. So at the very top, I create the object. So remember, we have the name of the class with parentheses, and then the word new in front of it to showcase we want a new object of this class type. So I'm going to save it into a variable obj for object, and it has a type of my class. And then I'm going to use the methods with the dot operator, which I mentioned on the previous slide. So if I can't really cover it, but if I were to call print num without the obj dot in front of it, if I just say print num, it's going to give me an error, and it's going to say, I don't know what print num is, because I didn't define a function just on its own called print num. The function is a method that exists only inside of my class, right? So that's why I need obj, which is of type, my class, dot, and then whatever I want to access. So what I do is I access and call print num, and then add 5, and then print num again. And so you can see on the output here, it's going to print 5, because that's the default value. Then I'm going to add 5 with my method, and I'm going to print it out again, which is why we get 10, right? And then I'm going to use the property .mynum. So it looks the same as calling a method, but it doesn't have those parentheses because it's not technically a method, right? But we use the same dot notation. It's going to be very common to use dot notation with object-oriented programming. And I set it to -2 because I know it's setting it because my num is on the left side of this equal sign. And then again, I'm going to print it out, which is why we have my num is equal to -2. right? Does anybody have any questions on classes or methods or this example specifically?
If you make lowercase minor public, is it essentially the same as the property?
Yeah, so if you have, at the very top, if you say public mynum, then I can access mynum in my example with a lowercase letter. Yes, that is true. The reason why what I mentioned earlier, why we want to avoid that is essentially, I think it's kind of like you don't want the wrong class to kind of affect your fields directly, especially because here, in this example, in my property mynum, I have get and then I have set, which means anybody can read and also write the value, but I don't have to specify it. So I can specify just get, which means that anybody can read the value, but they can't set what it is. And so that's kind of like a common property you'll probably see is just the get method will be implemented. But yeah. Okay, so just a rundown of everything I talked about, which I know is very dense, but again, these are the same links from that one slide as we talked about variables, then if, else, and loops, and those if, else statements and those loops will most likely be within those methods of the classes that we'll be using. Then the functions, which are methods, so I might use the term interchangeably, but those are all encapsulated together into our classes that Unity uses, right? And so, yeah, any just general questions, I guess? I know I've been talking a lot, but okay. And if you want to learn more, you're like, Liz, I have never programmed before. I'm so lost. Please help me. I found some cool tutorials online. We have beginner-friendly scripting tutorials, which is made by Unity. It's a playlist on YouTube, and they have it like by topic. You could search what they offer. We have the Junior Programmer Pathway, which is basically they have so much content. I think it's like multiple courses and they're like 30 hours each and stuff like that. So if you are from complete scratch, they go over a lot in that pathway. There's How to Program in C#, which is a playlist by Brackeys. That one just focuses on just C# without Unity. And then the last one is the Unity tutorial for complete beginners. It's a 1 hour video by Game Maker's Toolkit, and that one has a focus of creating a project from scratch, but it does have some scripting, knowledge and tips in that video as well. Okay, so I want to quickly point out, basically, I want to take the player script that we made last time and point out a bunch of these things that I just talked about in that script, because I realized that I've been programming for so long that I don't even think about these things, and that's not true for everybody. So at the very, very top, we have a class, player, and mono behavior is another class type that Unity provides. And basically that little semicolon, it just says, hey, we're gonna take whatever methods and fields mono behavior as a class has, and I can use it as well. So that's what player has. And that's why, actually on this slide we just have our fields. So for example, speed, jump force, can jump, and RB2D are all fields because they're defined at the very top outside of any function. And then we have, for example, stuff like serialized field and rigid body 2D as a type. Those are Unity specific, right? So this is where we're getting into like, okay, you can learn C#, but it's still going to be very different to use it inside of Unity, right? And again, these fields, we can use them anywhere in our script. And so it's useful, so for example, on this next slide, we have these functions that Unity gives us. We have start and update, which came in your script by default. Those are methods that exist within the mono behavior class, but our player script can use them because we take them and we adapt them, basically. And so the reason why we have those fields is because we can use them both inside of start and inside of update and any other method that we define. So here at the top, last time on that last slide, we declared at the bottom here. We declared RB2D, but remember, we don't initialize it. And the reason, this will be pretty often, which is why I wanted to mention it, because a lot of times with components in our scripts, we want to get those components in the function start, right? So here, we're just initializing it. And so GameObject refers to the object that the script is attached to. So it has a type of player. And then we see that dot notation come back into play. So we're saying, okay, this object dot some method, and you know it's a method because it has the parentheses at the end, right? And so this get component is a method provided by Unity, and so we have rigid body 2D, and so this is where we initialize our thing. So it's just kind of explaining like, okay, we have a field, but we don't say what it is. Start is called when the object is created, and that's it. It's called once. So that's why, okay, we're gonna go get this component and save it in our script. And then we use it again later in our other functions. That's why it's a field, right? This is the update method. So we have at the top, we create a new variable direction, give it a type float, which I guess actually could be an integer, I suppose. Yeah, I guess I could double check. But we create a new variable, so it only exists inside this function. Input.getAccessRaw is another method provided by Unity. And as you see, getInput is probably a class as well. And then we see that dot notation again, where getAccessRaw is another method with the parentheses. But in this time, we have a parameter that we pass inside of the parentheses called, we pass in a string horizontal. Then we have, again, our RB2D comes into play again with the dot notation. So RB2D is also a class of a type rigid body 2D. And that class has a field named velocity. And it's public, so this is what you were talking about before. This is a public class, and we know it's a field because it's lowercase. Sorry, it's a public field. And so we can set it with whatever we want. So we're going to set it to a new vector, and we have the keyword new, so we're like, okay, we're creating a new object, which means that vector2 is a class. And so new vector to object, and we pass in some parameters with what we want the x and y value to be. So a vector, with mathematics, it has a x component, y component. If it's a vector 3, it has a z component as well. But we're working with 2D, game. So, and then we see more dot notation with rigid body 2D or RB2D dot velocity dot y. So you can go more. And the neat thing with Unity is that it will most likely, if you just press dot, it'll come up with a bunch of things that you can access, which is pretty handy. We have our if statement, really long condition inside of that if statement, and then we have these two ampersands, which is used as like and, so this and that. And then here is just another example of setting a value for our field. So even though at the very top our default value is true, now that I changed it to be false, it's going to stay false, right? Until we change it again. And so basically, I want to point out, like we talked about C#, and I just mentioned some things about, hey, this is what we use inside of the Unity scripts, but it kind of comes down to, it's like Unity has its own things. Like, for example, the star update, on collision enter methods. It has data types like rigid body 2D, and honestly, any component is also its own class, which is pretty neat. But then you're like, Liz, how do you even know all of this stuff? Like, where do you get all of these methods? Like, how do I find out? There's so much in Unity. How do I find out? I just kind of look it up. Honestly, like for example, right there, it's like how to check if two objects hit each other, and it says, oh, go use on collision enter, and then I look up again, okay, Unity using on collision enter for 2D games, and then a tutorial pops up. It's a lot of kind of like just looking it up or following tutorials, and also just kind of doing it. So I think my biggest advice is kind of like, if you want to learn Unity and learn various methods in Unity, and also just programming practice, is you just kind of follow on tutorials and just kind of do it. And sometimes it's like, okay, I don't know exactly what this is doing, but I'm just going to do it. And later, when you have learned more, you come back to it and you're like, oh, now I know what this means. There's the link to the scripting API if you want to read documentation, but it can be a little bit intimidating. So we have a bit of time left, because today's session is a little bit shorter, but I do want to kind of continue expanding our prototype, and also hopefully get you guys to do some stuff while we walk around. And so as a review of our outline of the game that we're making, we have, for today, what I want to hopefully do is we have a goal at the end. So I want to make this, again, where it's a prototype, so it's going to be ugly and temporary. But for today, temporarily, I want to make a goal at the end of our game that the player can, trigger. We have enemies that deal damage to the player, and then we have a pickup that has some sort of effect. So hold on. I guess I'll open my Unity project and also kind of flip-flop between slides and my Unity project. So if you guys have your project set up, hopefully you do. If not, I can help you after the session's over if there's any problems with that, or you can message me. But to showcase you, to show you what we want so far, these are going to be very similar because they're prototypes. I'm going to walk through with you guys on making the goal, and then hopefully other ones you can do yourself. But basically, what I want for the goal is we have a temporary goal object that has a goal tag. It has a collider component, but for colliders, again, it's like physics, but there's a little checkbox, which I'll show you where it can act as a trigger. So you're not actually going to hit it, but when you kind of go over it, like the computer knows, like, okay, we've kind of overlapped, right? And so it can do different things based on that. And basically, when the player collides, or when, that's supposed to say enters the trigger, but we want the basically to just print out that the goal is reached. We're gonna do more fancy stuff later, but for now, I just want to use this debug log. And so, let me sit down. I'm gonna open up my Unity project. So this is the project based on if anybody has the project downloaded, if you joined today and you didn't do the workshop last week, on my GitHub repo, which I linked in both the email and the Discord announcement, I provide the materials for you guys to be able to set up the project based on where we left off last time. And so this is where we left off last time. But we have our little game here with our little guy that can move around and jump. Okay. Awesome. And so I'm going to, based on our slides here, so it's like, okay, we want a temporary goal object with a goal tag. Great, I'll make that right now. So I'm going to go in, I'm going to create a 2D object, sprites, and another square. I mean, I guess you can make it whatever sprite you want, but I'm just going to make it a square to make it easier on me. And then I guess I'll make it tall, and I'll give it a different color. I'll make it green because green is good. I'm going to name it goal at the top. With this move tool selected, I can move it as well. So I'm going to move it to the right. I guess I'll move it down. And based on last time, we have tags. So we have this ground tag we created last time. I'm going to create a new tag and call it goal. Actually, I think we can call it goal. I think Unity has this finish tag. So you can use either the finish tag that Unity provides or your own tag if you'd like. So that's up here, which is awesome. Okay, so we created a temporary goal object. Okay, so we want a collider that acts as a trigger. So I know how to add components to my object, which in my inspector window, when I select the goal object in my view, I'm going to add a component. And I can just look up box collider. Awesome. And so now we see that it is indeed a collider. But we want it, if you open it up by clicking that little arrow on the left, we make it a trigger, right? And so I'm going to demonstrate real quick. If we don't make it a trigger and we run our game, then, okay. But obviously, our player doesn't move past the goal, which makes sense because it's a collider. But in this case, we have, if I check is trigger, then we won't be colliding with our goal anymore, right? So we pass through the goal. And the reason why that happens is because now it's not exactly a collider, it's now a trigger. And so we can check this by going into our player script, which is now, by the way, heavily commented. So if you want this commented version of your script, I can show you how to get that. But basically, I'm just going to scroll to the bottom. So remember, last time we have on collision enter. So when we collide with something, there we go. That's the function that we use, which is built in by Unity. It's provided by Unity. We want to use a different one. So I'm going to type on trigger enter 2D and press enter. And that's the signature that we get. Automatically, it's filled in, right? So this on trigger enter collider 2D collision is made by Unity, right? And so I'm going to check right here. So on trigger enter, I'm just going to say debug log trigger entered. Okay? And so so now, when I have the game running, again, we have this console window on the bottom right next to our project. And so when I collide with my goal, trigger entered, right? And it only happens when we enter, not when we stay, right? Great. And remember, we added a tag to our goal. So we just want to mimic right here what we have for our collision, right? So based on our what we want, so we have when the player collides, we print out goal reached, right? So here I'm going to check, okay, I'm going to mimic this. So if my collision, which is a type, remember, see, it's a type of collider 2D, so if I press dot, a bunch of things come up. Well, I want game object, right? And I know it exists, so I'm going to type a lowercase g and it pops up. And then if I type dot again, it's like, okay, the game object, what properties and methods does the game object have? And I know that this has a tag property, so I'm going to check that this is indeed the finish. And then here I'm going to say debug log goal reached, which will work the same way. But then when we add other things and other triggers, this will only print it out when I interact with my goal. Goal reached. Awesome. And so obviously we want probably our game to do something cooler, but we will set that up later down the line. For our prototype, this is good enough. It does what we want, basically. Because down the line, if I want to do something else with this, all I have to do is replace this line. So instead of debugging, I'm going to do something else. Okay, so now we have an enemy object, right? So we have a temporary enemy, and I say that I want a damage tag because theoretically in my game I could have multiple sources of damage, not just my enemy. And also I'm going to create a new health field inside of my player script, and I'm going to have some default value. I think mine is set to like 5. The enemy itself has a box collider, but again, it acts like a trigger. And when the player collides with the enemy, the player's health decreases by 1, and then we print out what the health is. So it's very similar to what we had just now did with the goal. So I want you guys to try to do this, and we can walk around and help. I want to showcase real quick an enemy, since it's going to be very similar to the goal. So if you don't have the goal, you'll follow very similar steps, and then that'll be it for the workshop. So I'm going to go back to my project, and so again here we have a temporary enemy that has a damage tag. Okay, I can do that. So also just to point out, if you are playing the game, it's going to have a blue arrow up here. So you can check, and you can go back to your scene and still do things, but just when you stop playing the game, any changes you make will undo themselves, which is not fun. So just make sure that whenever you're, implementing things, you want to make sure you're not playing by checking up here. But I'm going to create a prototype of an enemy. So 2D object sprites again. Another lovely square, because we love squares. These are all temporary, by the way. The next workshop is going to be artwork, so it's going to look pretty after next workshop. I'm going to make it red because red is evil. And I'm going to put the enemy over here. So this is kind of personal preference. It says right here it has a box collider. So I'm going to, as I did for my goal, I'm going to add a box collider. And this is kind of up to you guys, where if you want to make your player physically collide with the enemy or just be able to kind of walk through them but take damage. For my game, I'm gonna make it a trigger where it's not colliding with my player, but it's up to you guys, and we talked before about how to do collisions. But I'm gonna name this enemy, and I'm gonna give it a new tag called damage. So I create the tag, I have to go back and give the tag. Right? Because again, we could theoretically have multiple damage sources from inside the game. So then, that's all the setup that we need for our enemy here. And back in my player script, actually here we have, the player has a health field, right? Because inside of this, right, we could do an else if, right? So, else if collision game object tag is with by the way, just to point out, it's 2 equal signs because we're not setting the tag to be damage, we're checking if it's equal. So if you want to check for equivalence, you use 2 equal signs. But in this case, I'm going to say debug log. Oops. Enemy hit. And at the very top of my script, I'm going to add, I guess it could be anywhere, but I'm going to add an integer because I'm going to have the type of game where it's like my player has like 5 health or something like that, and then my enemy does 1 health per hit. So I'm going to say health is 5. And then down here, all I'm going to do is say my health is minus minus. So this is the same thing as plus plus, where plus plus adds 1, minus minus subtracts 1. And then I'm going to say enemy hit, health, and then a plus health. And as you see here, like when we want to print out stuff to the debug log, I use this plus sign to essentially add something that's not a string to something that is a string. And it just appends it to the back, right? It just adds it to the back. So I'm going to go back to my game and we're going to test this out. So theoretically, you should start with 5 health, and then when I hit an enemy, it should print out the fact that, I hit an enemy. So I'm going to actually do that. So when I can't, hold on. I can't see the console if I do that. Okay, that's fine. So when I go to my goal, awesome, we reached our goal. But when I go to my enemy hit, now we have 4 health, right? Then enemy hit, now we have 3 health. And because we did this on trigger enter 2D, on trigger enter specifically, it's not going to do anything when I'm still inside the enemy, right? See there, I kind of wiggled and touched it twice. But when I enter the thing, it just, it doesn't still do damage to me. And also with the fact that what I programmed so far, I can have negative health, right? So what I could do, finally is, obviously if I have 0 health, we die. So I'm going to do here, if, again, I'm going to check if my condition is less than 1, so if it's 0 or any negative or whatever, I want to destroy player. Player has died. Yes. And what we can do is just, there's actually a Unity function called destroy, and then we pass the game object that we want to it, which I know because it's super tiny. But the one parameter that you need to give it is, it says it's an object of type object. So, and when you hover over it, it kind of tells you what it's expecting. And I'm just going to pass in this object, which again, the one that the script is attached to is a lowercase g. So I'm saying if my health is less than 1, after the trigger has happened, I'm going to destroy the object that this script is attached to, which is my player object. So what happens is, so we have 4 health, then 3 health, then 2 health, then 1, and then goodbye. And you see on the left here, my player object is no more, right? So then goodbye. And that's that. And then when we, stop playing, obviously our player is back because anything that we make while we play anything that happens doesn't stick around. And yeah, let's see. And that's it. So I can go over and help anybody out for a couple minutes, and then obviously you could still reach out and stuff. But basically, if you want to do some more stuff after today's workshop, you can create other objects that you for your game. So we have so far an enemy and a goal. Next time we're going to talk about pickups and timers. Well, not time, I guess. Next time we program, which is in 2 sessions. So for now, you can think of whatever else you want. And then you can look into any of those programming concepts that I provided links to if you're a little rusty on that. And yeah, that's it for me. Next time we have artwork. So not next week, because next week is fall break. The one after that, I will send out announcements and stuff. But it's all artwork. So also, if you know any of your friends that want to do game development, but in a team maybe, and they don't want to do any programming, that's basically like they want to come to that workshop. And yeah, if you want to scan the QR code and give me some feedback, that would be very appreciated. And again, that's the links for Discord and listserv. And then, reach out to me. If you have any questions about anything, I'm always willing to respond. So thank you for coming.